Here's the first scenario, and I actually found this quite interesting. So, Pamplemooses, it's a funny name. Pamplemooses Botanical Gardens are known for their giant water lilies that grow in a circular shape in the ponds. Each water lily has an approximate radius of 1,25 meters and can support a weight of up to 45 kilograms. The diagram below shows a picture of the water lily and dimensions of the pond. All right, now, I didn't believe this at first. I did some research and it's a fact. You can see there's an image of a guy standing on this water lily, which is floating on the water. It's incredible. You get water lilies this big. They're actual things, and you can stand on them. That's incredible. All right, so there's a pond, and these circular water lilies are floating on the pond. Hey, they'll use any kind of context in a mathlet question, eh? Oh, sorry, Kaleko. Yes, this load shedding is still a thing. Still a thing. All right, so yes, those are water lilies. They get that big. Now, the one in the picture, I think, is bigger than 1,25 meters, but we'll use the facts given to us. And that guy that's standing there looks bigger than 45 kilograms, but again, we'll use the facts that are given to us. All right, let's see what questions they can ask about the water lilies. Ah, there we go, some more information, the dimensions of the pond. So it's a rectangular pond, okay, and it has a length of 100 meters and a breadth of 25 meters. Doesn't really look to scale, but remember, on the front of all the exams, you should get an instruction to saying drawings are not necessarily to scale. So don't trust the scale of the drawing. You trust the facts given to you in the question. Also note at the bottom here, we have a conversion. If they give you this, maybe they want you to use it. Hashtag just saying. All right, moving on to the question. Let's see. Assume that each water lily has the same radius. Determine the number of water lilies leaves that will fit along the length of the pond. So we're talking about in this direction here. How many water lilies can we fit along that dimension there, which is 100 meters? All right. The water lilies are 1,25 meters in diameter. So what I'll do is I'll draw a little circle here. I'll draw a little diagram on the side so we can use that. Whoopsie. All right, the water lily has a diameter. Let me just check. No, radius. I said radius. So the radius of the water lily is 1,25 meters. I'll check on that again. And we have the pond, which is a rectangle, and they say the length is 100 meters. We want to know how many lilies can we fit along the length of this pond. Let me just check. Radius is 1,25 meters. Radius, yes. All right, there we go. So that's all the information that we need for this. Who would like to come online and let me know how to do this one? Nice and easy, shouldn't be difficult. How many water lilies? Yes, Ben. Good old Ben. Never scared to try and answer the questions. Yes, Ben.
Hi, sir. How are you doing?
You nearly at the end, eh?
Yes.
You
Tomorrow's the last one.
You must be so happy.
Yeah.
You're gonna have a good. So obviously you don't go back to school after tomorrow, so you're gonna have a little bit extra time on your holiday.
Yes.
Awesome. That's like a week and a half. Fantastic. All right, Ben. How do we do this one? How many lilies are there along the length of the pond?
Since the diameter is 1.5 meters, 1.25 meters, I divided it by 100 meters, which is the length.
Okay, you got the right idea. We want to divide the length up by the lilies, and then we want to fit them all in. But we've got to be careful because we're going to fit them end to end, obviously. So if I copy this, whoopsie, if I copy this over here and I put it over here, we want to put the lilies next to each other, one next to each other like this, and keep putting them like that in the pond. All right, so there is important information about this lily that we need. We actually need to know what that distance is over there, because we're going to put them next to each other like that. So we need to know what those distances are, Ben. So I think we should use not the radius, but the diameter.
Yes, it's 2.5.
Yeah, so we need to take that radius and multiply it quickly. So let's quickly do that. So you get the diameter, take the radius and multiply by 2. So the diameter of the lilies is 2.5. And then like you said, we're going to take the whole length, 100 meters, and divide it up by 2.5. We want to know how many lilies can you fit in there, and that should give us our answer. So let's check. 100 divided by 2.5, 40. Yo. All right, 40 lilies. You happy with that, Ben?
Yes, that's the right answer.
All right, cool. Thank you. Well done, Ben. Thank you very much for that. All right, so just remember that we want to pack the lilies next to each other, okay, in this pond. So when we do that, they're going to sit next to each other. And so we need to know the length across the lilies. So that we're going to have to use the diameter for that. We got the radius, we just multiply it by 2. All right, not too bad. Not too bad for a first question. Let's see what else they got. Second one below. You guys can do this one. Determine the number of water lilies leaves that will fit along the breadth. Now, I'll give you the dimension for the breadth. As far as I can remember, it was 25 meters. All right, so you guys should be able to do this. 2 marks. You can do it quickly and then spit out the answers. The breadth is 25 meters. They want to know how many lilies can we fit along the breadth. Same kind of question. You guys should be tapping on your calculators now, writing it down. If you've got an answer, post it. Tanda, I think we need to go the other way. That looks very small. Maybe you divided there. I think you might have divided, Tando. All right, so we've got some answers coming out. Well done, Sfiso. Well done, Ben. Okay, we're going to apply the same method. Our breadth is 25. We're going to divide by 2.5. And that will give us 10 lilies. All right, so it's the same idea. All right, we now know that the diameter is 2.5, which is why this question here is 2 marks and the top one was 3, because you had to work out the diameter in question A and you're using it now in question in B, so you don't have 3 marks in question B. Yes. All right. Okay, not a problem if you divide it. So we get an answer of 10 lilies for the breadth and 40 lilies for the length. All right, let's see what's next. What else they got? Aha. Calculate the total number of water leaves needed to cover the water surface of the pond. Now, I don't think they mean that you're going to have green leaf everywhere. There's obviously going to be little gaps because there are circles in a rectangular pond. And when they sit next to each other, there's going to be gaps. So don't think that you have to work out the whole area of the pond. These are just how many lilies can you fit? Okay, how many lilies can you fit in? Well, we know that the pond going this way, lengthwise, can fit in 100. I'm sure we'll see answers popping up soon. And we know this way, not fits in 100, 40. We can fit 40 lilies in that way, and we can fit 10 lilies in this way. All right, and we want to fill this whole area with lilies. So therefore, how many lilies will we have? You guys should be able to do that. 2 marks, nice and easy. If you've got an answer, then put it onto the screen there, put it into chat, or you're welcome to raise your hand, come online and tell us exactly how you did it to get the number of lilies in the pond. We've got 40 lilies going lengthways and 10 lilies going breadthways. Well done, Sophie. So we need to multiply the 40 lilies along the length by the 10 lilies along the breadth, and that'll give us 400 lilies. Okay. All right. Well done. Good job. Yes. Well done. Okay. So it's very similar to if you've got a diagram where there are markers or marbles or anything like this, and they're all stacked in a rectangular shape. They want to know how many you have there. You just multiply how many you have lengthways with how many you have going breadthways, and that'll give you the total. All right. That's exactly how we do it. Okay. Nice and easy. Nice and easy. Let's see now what the next question is. We're starting off easy tonight. You know, we end in the deep waters, hey? That's what we do. So here we go. Determine how many leaves, lily leaves, would support 1.8 tons if each leaf supports 45 kilograms. Huh. We need to support 1.8 tons. That is huge. Maybe there's a little bit of weight on each one, and altogether it makes 1.8 tons. So how many leaves would we need to support 1.8 tons if each leaf supports 45 kilograms? All right, I'll give you guys time to do this one. You do it on your own. Put a thumbs up in the chat if you've finished, or you can put your answer there if you want. How many leaves would we need? We need to support 1.8 tons, and each leaf is 45 kilograms. How many leaves would we need? How many lilies would we need if each one supports 45 kilograms? You guys can do that. Take you a minute or two, and then we'll go over it together. All right, so I'm not going to do anything now. You're going to try it out. You try it out. How many leaves do we need? Each one supports 45 kilograms, but we need to support 1.8 tons. How many leaves do we need? Let's see what you guys get. All right, we got answers coming out. How was saying 40. Phew, doesn't sound like a lot, eh? 40 leaves when you carry 1.8 tons. But these leaves can do some work. They can hold a man. All right. Got some answers coming out already. You guys do it, and we'll see. Okay, Thunder, you're on the right track. You're on the right track, but just be careful because the question gives you tons and you're dividing by kilograms. You must divide by the same unit. So one of these units has to change. All right, so your method is correct, but you can't divide tons by kilograms. You've got to use the same units. Don't worry, Maria. I've got 25, I've got 40. I wonder which one is correct. All right, you got to work with the same units. All right, Lindsay's also there, got some units. Hope you guys have done it, either on your calculator or your piece of paper. Answers are coming through. All right, should be done by now. Let's have a look. So like I said, we got to work with the same units here. We've got tons and kilograms, right? So we got to change the units. I'm going to change the tons into kilograms. Now we know that 1,000 kilograms is equal to 1 ton. Okay, so if I want to know how many kilograms in 1.8 tons, I'm going to say my 1.8 tons times 1,000, and we know that'll give us 1,800 kilograms. Okay, then we divide. Tando, so like you tried there, you must divide, but you must divide with the same units. So we'll divide the kilograms and the kilograms. Okay, so 1,800 divided by 45, and like you guys told me, it will give you 40 lilies. So that's incredible. 40 of these leaves can hold 1.8 tons of material. Sure, that's incredible. Any questions about this? Are we all good? Going back to the picture, yes, look at that. A huge leaf can carry that guy. You need 40 of those, and you can carry 1.8 tons. Sure. That's incredible. All right. Are we all good? Can we move on to the next question? If not, please raise your hand. We don't mind stopping at any point. Whoa, 7 marks. Finally, we get to the meat, the rump steak of this question. Here we go. Jody states that the depth of the pond should be less than 1 meter. Every time I use those words, people like Siam are like, oh no. Jody says that the depth of the pond should be less than 1 meter for the water lilies to grow. The pond needs to be less than 1 meter for the water lily to grow. Determine the depth of this pond if it has a capacity of 2,285,000 liters of water. So we need to know how deep this pond is, because it's got to be less than 1 meter for these lilies to grow. If it's not less than 1 meter, if it's 1 meter or more, the lilies won't grow. Okay, so we need to check how deep the pond is. Now, I'm going to draw a quick sketch here. Okay. Please don't mock my drawings because I'm not an artist. All right. But it's a rectangular pond. Okay. And we know the length is 100 meters. We know the breadth is 25, but we don't know the height. Okay. We know the volume. They give us the volume of this pond. Actually, I lie. It's not volume, it's capacity. They give us the capacity of this pond. They say the capacity of the pond is 2285000 liters. How deep? Now, deep is length, right? Deep is length. So the pond's dimensions are already in length. We've got meters for the length, meters for the width. Obviously, they want to know how many meters is the height of the pond. But they give us volume and capacity. And they say, use this formula. Now, Tando, I'll go up in a moment. I think you were looking for the conversion. I'm going to write it down here quickly. There it is. So 1 cubic meter is equal to 1,000 liters. That's the conversion. Tando, is that what you were looking for? Or were you looking at the previous question? Do you want me to go to the previous question? So, ladies and gents, I want you to try this. Often in the matric exam, they'll give you a question like this, where you don't get given the length, the breadth, and the height, and then you work out the volume. They give you the volume, and you got to work out the missing dimension. We practiced this last week as well. So you guys should be able to do this. You got to fill the equation. That's all I'm saying. I'm not saying any more. All right, I'll go back up there now. There we go. All right. I hope that's okay, Tando. There we go. There's our question. We need to know the height. I'm going to give you guys some time to do this. And then we're going to check, because we practiced this last week, eh? So if you remember how we did this last week, you should be fine. Maria's looking at the screen like, what do I do now? Where do I even start? I'll give you a clue. Start with the formula. Start with this formula. Just remember, like I said in the previous question, you got to work with the same units in the formula. All right. What units did they give us? They gave us a breadth 25 meters, a length of 100 meters, and a volume in liters, which is no good to us. We've got to have the same units before we go to the formula. Shouldn't take you long, guys. Don't worry about how many marks this is. Step by step, little by little. I'm throwing you into the deep water here. Let's try this one on your own. People are looking at the screen. Ndenengwa is working. Ndenengwa is working there. I can check. Good job. Anyone have any questions about it? That you may be thinking, sir, but I don't know about this. Maybe what any questions before you want to try? Anything that's worrying you before you try this one?
Oh, Ti amo. It's a classic.
Oh my gosh. How do we find H? Yes, that is the question. How do we find H? So I'll give you another clue. Look at their formula. They give us volume, they give us length, they give us breadth, but they don't give you the H. That's what they want you to find. So substitute everything you have into the formula, and then you're going to have to get that H by itself. We practiced this last week. But like I said, when you put things into a formula like this, all the units have to be the same. You can't work with liters and meters. All right. So what they did was they gave you this conversion. You got to do something with that before you put the volume into the formula. Yo, I'm giving it away now. This kind of question always comes up in the exam, eh? All right, Itumeling's got an answer there. Good, well done. These are real world issues. Bathlets is real world problems that are being solved here, guys. We need, you could be someone that looks after a pond with all these lilies. Maybe you work at a botanical gardens and your boss says to you, listen, we want to get these huge lilies in here. Everyone's going to come. We're going to make a whole lot of money because the people are going to visit to come see these lilies. But we need a pond that cannot be more than a meter. Can you please check if the pond is more than a meter? Now, I know what you're thinking. Just get the ruler and go to the pond and put the thing. Yes, I know. But we've got some information here. You can do a quick calculation to figure this out. All right. So it's not just trigonometry and functions and parabolas and things like that. This is real world math that we can use. All right, we got another answer there. 215, 215 meters or centimeters? Because 215 seems very big. Maybe that's centimeters. Maybe. We'll give you guys a minute or two. You can see Maria's working hard there. Good, excellent. Good job. Denenga, I think, has tried something. Well done. One more minute, guys, and then we'll try this one out. I remember last week Ben explained this type of question so well. He came on and helped us with something similar to this, where we subbed into the formula and then we moved the numbers over to the other side, or we got rid of the numbers that we didn't need to leave the one that we wanted. All right, let's have a look. Okay, so we need 3 things in our formula. Like I said before, let me rub this out. Okay, they give you a formula. You got to check what do you have in your formula. They give us a volume. They give it, we know the length of the pool, we know the breadth of the pool, we don't know the height. That's what they want us to find. Now, it would be easy if they gave us the volume in meters cubed, right? That would be easier because you'd throw that straight into the formula. Instead, they make it a little bit more complicated by saying the volume of the pool is in liters, which is capacity, not cubic meters, which is volume. All right. So we have to change from liters into something that we can work with. And then they give you this conversion. So we must use that conversion to go from liters to meters cubed for volume. Okay. So if there's 1,000 liters, if 1,000 liters is 1 meter cubed, how many of these thousands do we have in here? That's the question. You guys know what to do. We got to divide it, right? We got to cut up this 2,285,000 liters by 1,000 liters, because each 1,000 that's in there gives me 1 meter cubed. So 2285000 divided by 1,000. 2285. All right, so this gives me 2285 cubic meters in my pond. Now that is a number I can work with. That now can go into my formula, because look here, I've got volume in meters cubed, I've got length in meters, breadth in meters, and my height, when I find it, will also be in meters. Okay, so now we're going to go to the formula. So we put in our volume on the left-hand side. Right? If you look up here, volume goes at the left in our formula. So the volume must go in here. Equals our length, we know, is 100 meters. Our breadth, we know, is 25 meters. It's just the height. I'll just write H. All right? No, it's not core massive variables. It's just H for height. That's all it is. Now, we got to get this H by itself. Now, I remember when Ben did this last week, he said, sir, before you start moving these numbers here around, first simplify this, multiply them together. Okay, so that's what I'm going to do. Okay, so 100 times 25, that's 2,500. So 2285, I'm just rewriting this, is equal to 2,500. And by the way, this is actually meters squared, but don't worry about that. And there's the H. I want to get the H by itself. How do I get this H by itself? What do I do to get rid of this 2,500? Yes, you know, guys. How do you know it's divided? Because it's attached to that H with the times. We're going to do the opposite. So we're going to divide this thing by 2,500. All right? But what you do on the right, you got to do on the left. Okay. So dividing by 2,500 will get rid of that 2,500 on the right. So now we're just left with the H. It's just the H now. Okay, so the H is on its own here, and the H is equal to what's on the left there. So we're going to say 2285 divided by 2500, and that'll give us 0.914 meters. Okay. All right. No worries, Taran. Yes, Itumeleng. Safiso had it there. Well done, Safiso. Itumeleng had it. Yes, good. Well done, well done, well done. All right, good job. Okay, so the height of the pool is 0.914. So can they have these lilies? Yes, they can, because the pool can't be a meter or more. It has to be less than a meter. That is less than a meter. Therefore, the pool can have the lilies. They can put the lilies in the pool. Yes, they can. This question. All right, Denenga, it's not easy. It's not an easy question. So I'll go up to the question in the moment. I just want to show everyone there what we did. All right, so let's read the question again. Jody states that the depth of the pool should be less than 1 meter for the lilies to grow. So you need less than 1 meter in the pool. All right, determine the depth of the pool in meters. If its capacity, and they use the word capacity. So this is why we talk about, in one lesson that we did this year, we spoke about the relationship between capacity and volume. All right. Capacity is in liters, milliliters, kiloliters. All right. Volume is in centimeters cubed, meters cubed, kilometers cubed. That's volume. All right. So capacity has got those units and volume has got those units there. So we can't use the volume formula that they gave. Let's say use this formula. We can't use the volume formula if they give us the capacity, which is in liters. We've got to change it. So we have to look for something to help us change the liters into cubic meters, which is volume. And they gave us this conversion to use. So we take this conversion and we change our liters into cubic meters, which is what we did here. We said divide by 1,000 because every 1,000 liters in this pool is 1 cubic meter. So we change to cubic meters first. Once you've got cubic meters, now we can go into the formula. You can't put liters into the formula because the formula is for volume, first of all, and also the other units that you had in this question are in meters. Look on the right hand side there. Those are meters. You can't have liters and meters in the same formula. You got to have everything the same in the formula. Okay. So something's got to change. So we change the liters to cubic meters, and then we could put it into the formula. All right. So this is us now substituting all our values that came from the question. That one came from the question, but it was in liters, so we changed it. This came from the original question. That came from the original question. This is the one they want us to find. So you put all the things that you have, and you left with one little thing that you need to find, the H. Now you can do some math. This is when the math comes in. So what you do is we're going to simplify these two, make them one number, which we did. It was 2,500. Then we're going to say, I want to get that H by itself in this equation. So get rid of the 2,500. How do you get rid of it? Well, it's linked to the H with times. So we will use divide to get rid of it. So that canceled out the 2,500 on this side. But what you do on the right, you must do on the left. And therefore, H will equal all of that. Okay. So that H came to 0.914. All right. And they said the pool needs to be less than a meter. Well, 0.914 is less than a meter. Oh, I like what you did there, Kia. Brightest lilies in the pond. That was a good one. Okay. Not an easy question, but it often comes up, hey? It often comes up. All right. So a grade 10 thing is take a length, take a breadth, take a height, all in meters, put it into the formula and work out the volume in cubic meters. Grade 11 will be maybe take a length that's in meters, take a breadth that's in centimeters, and take a height that's in millimeters. What is the volume? You got to convert things first. You can't have millimeters and centimeters and meters all in one formula. You got to get the same units. Matric, they take the same formula and they give you the answer and they take one of the other dimensions away. All right. So this often comes down. Safiso, you broke down everything but got the same answer. What do you mean that you, Safiso, come tell us here? Check your screen there, Safiso. Just explain what you mean by you broke it down.
Good.
You there, Safiso? I think you might be having internet issues. Could be connection issues. Just type it in chat if you can't speak to us because of connection issues. Just put it in chat there, we'll have a look at it. All right. Okay, hold on.
Good day, sir.
Hey, there we go. How you doing?
I'm good.
I'm good. What do you mean by you broke it down and got the same answer?
So I started dividing by 100, and then I divided by 25, and then I got the same answer.
Oh, yes, that's fine. You can do that because you see both numbers are attached to the H with times. They're both being times with the H. So you can divide by 100 first and then divide by, yeah, that's fine. That'll do it. That'll work as well. Not a problem. You'll get marks for that. Well done.
Oh, okay. Thank you.
Awesome. Okay. All right. Next question. We're moving on from lilies to marbles. All right. From lilies to marbles. Hey, they can put anything in the exam, eh? So let's read this one. It says, Lindiwe bought 2 bags of dirty marbles. She bought 2 bags of dirty marbles from her neighbor at 30 Rand per bag. Each bag contained 100 marbles. She intends to wash the marbles before selling them to her friends at school. That's very clever. She uses a cylindrical container to wash the marbles in, as shown in the diagram below. So there on the left, we have a cylinder. We all know what a cylinder is. And then on the right-hand side, we have this bag of marbles. And on the bottom here, they give us the inner diameter and inner height. Now, what does that mean, guys? What do they mean by this inner? Who can come online and tell me, what does it mean when they start talking about inner diameter and inner height? Anybody?
Somebody. Ben to the rescue.
Ben, is there somebody's Ben? Yes, Ben.
So are they not talking about inside the shape?
Yeah, inside. Okay. Oh, jeez, I'm gonna try and draw this now. So, inside the cylinder. So, oh, sure, but that's a horrible looking cylinder. But anyway, guys, please don't mock my drawings. All right. So there's a cylinder. What they're talking about is they're saying that the cylinder actually has a thickness. Okay. Oh, yeah, it's not very good. But anyway, I'll try to draw it as best as I can. So they're saying this container has thickness. Okay. It's actually got a thickness to it. The metal container, or whatever it is, plastic, or whatever it is, has got a thickness. And the inner diameter is on the inside. All right. So that's on the inside of this. So if you have a tube, all right, like this, and then I'm going to draw another tube as well, like this. I'm going to make this one smaller, a little bit smaller, and then I put it like that. Okay, so let's say we're looking at a pipe now, the bottom one. We're looking down the pipe. The inner diameter is this one on the inside here. The outer diameter will be all the way to the edge. Okay, so the red diameter is the inner one. The blue one is the outer diameter. Okay, so that's what they're talking about here, the inside. All right, so this obviously, when they say this, it obviously means this cylinder has a thickness to it. All right, so there's a thickness that we have to consider here. Okay. Yeah, so that, like if you talk about toilet paper roll, that cardboard piece in the middle of a toilet paper roll, the cardboard tube, the diameter on the inside of that. Okay. The outer diameter is all the way to the edge, like that blue arrow is showing. All right. So that's what they mean by inner. Okay. So the inner diameter is 64 millimeters and the inner height is 30 centimeters. And on the right-hand side here, we say the volume of a single marble, the volume of a marble is 2 cubic centimeters. Interesting. All right, let's see what questions they are talking about here. Oh, there's more. You may use the following formula when you answer this question. Volume of a cylinder. If they're giving it to you, they're expecting you to use it often. And then they also give you the circumference of a circle is 3.142 times diameter. Just remember that. At the bottom, 1,000 centimeters cubed is 1 liter. There's a conversion. Maybe they want us to use it. Let's check. First question. Calculate in centimeters the outer circumference of the cylindrical container used to wash the marbles if the container is made of a metal that is 0.5 millimeters thick. There it is. Calculate the outer circumference of the container if the container is 0.5 millimeters thick. Now, guys, you got to picture it. I'm going to bring this diagram down. Okay, Let's picture it now. So we're looking down into the container. Okay. We don't know the diameter from the outside edge to the outside edge. All we know is there's an inner diameter here. Okay, and I'll draw it on here. They said the inner diameter is 64 mils. They want to know what is the circumference around this circle, okay, if this container is 0.5 millimeters thick. So this part here, this thickness here is, I'm going to draw a little blue arrow. Teeny tiny little arrow. That blue arrow there is 0.5 in length. Okay, so this little arrow here is 0.5 millimeters. All right. They want to know the circumference. Now, I wonder if I should say anything or if I should let you guys try. No, the next one's even harder. Or I'll give you a clue on this one here. Circumference, they say for circumference, you got to say 3,142 times diameter. So then all we need is a diameter for this thing, if you want to work out its circumference. But how do we work out the diameter of this thing? This is the information that we've given. What do we do? Anybody?
Somebody.
Yes, Itumaleng, saying you times it by 2. Yes, Itumaleng. We need to take that red dimension, the inner one, and add on the thickness on the left and the thickness on the right. We times it by 2, and we make it all one line. So if I draw a green line here, we need to know the whole diameter across, right? So we take the inner one, and we're going to add on the thicknesses as well. So we're going to say, well, let me put a D here. All right. So D for diameter is 64 millimeters plus 0.5 millimeters times 2. Okay. Please note, I'm checking. And this is why Kia always said, show your unit. Because you've got to make sure you have all the same units in here. If they gave us this diameter here in centimeters, we would have to change it. All right, but they give us millimeters in our dimensions, so we're going to use them all the millimeters. They're all the same now. We're good to go. So what is the diameter of this actual circle? 64 plus 0.5 plus 0.5 is 65. Yes, that is the real diameter of the circle. Okay, 65 millimeters. And now they want to know what is the circumference. Well, we've got the formula for the circumference. C equals 3,142 times 65. That's easy. 3.142 times 65. 204.23. 204.23 millimeters. That's not so bad. That's not so bad. Okay. Now, I know what you're thinking. I would never know where to start. I don't know where to start. Okay. In measurement, a lot of measurement questions have a formula. All right. They want you to work out circumference, and they give you this formula. An easy question is, they tell you the diameter across the circle. That's easy. That's grade 9 or 8. Okay. You guys are higher up now. So they're going to try and make it more challenging by not just giving you the straight diameter. They say, oh, it's not the diameter across the circle. We'll give you the inside of the circle. And then later on, we'll tell you that there's actually a thickness to this thing as well. That's fine. We can work out the whole thing, right? So this diagram that you see here on the right-hand side, if you want to draw it out to visualize it yourself, you can, or it's in your mind's eye. You need to know what to do. So this picture could be in your head, and you're working it out in your head, or draw a diagram like this. I know that if I gave you a diagram like this, you guys would know exactly what to do. Okay, so draw a diagram, take the formula they give you, and you need to put the things that the formula needs inside there, making sure the units are all the same, and making sure you've got all the information that's given to you in the question. All right, so that is the circumference of the circle. We're going to end off tonight with a bang. You know what I'm like. Yo, 9 marks. Let's see who can swim in the deep water with the sharks. Now you look at the 9 marks and you think, that's not for me. Can't do that. Can't do it, move on. No, we break it down. How do you eat an elephant? Piece by piece. We break it down. Let's see what the question says. To wash the marbles, Lindiwe placed all the marbles from both bags, 2 bags, into the container. She then filled the container with water. She states that more than half a liter of water is required to fill the container with the marbles inside. Verify whether that is valid. She's saying you need half a liter of water in this container with 2 bags of marbles. Okay, you need 2 bags of marbles in here. And when you pour the water in, you're just going to get half a liter. Now, I'll give you a clue. I'll give you a clue. We know, let's go up to the top here. We know the volume of 1 marble. How many marbles do we have? That's what we need to know. Well, she says each bag contains 100 marbles. And we're going to put 2 bags, so 200 marbles, each one with a volume of 2 centimeters cubed inside this container. And we want to see how much volume those marbles take in this container. So we need to know the volume of that container. Because once you put all the marbles in, they will take up a space in the container, a certain volume. All right. Well, what is the volume of the container? First of all, we can work out the volume of all the marbles and find out what the difference is. The difference of the container and the volume of all the marbles. It's not that bad. That's a good question. That is actually a very good question, Tando. Did she use 2 containers? Let's go down. Does each bag go in a different container? Good. To wash the marbles, Lindiwe placed all the marbles from both bags into the cylindrical container. So it's just 1 container. All right. She's not putting each one into a separate container. It's the container that we're talking about in the question. Now, let me go ahead and put this information in diagrams for you. All right. Cylinder. All right. Its diameter, internal diameter, all right, is 64. That's all we need in, or 65, 64 millimeters. Its height is 30 centimeters. Ooh, guys. Its height is 30 centimeters. And they say you must use the formula for volume. V is equal to 2 pi r squared times height. That's the volume formula for a cylinder. They tell us that the marble has a volume of 2 centimeters cubed. No, we don't need to divide both containers. We're going to use just the 1 container. Okay, so like I said, and we got 100 marbles, 100 per bag, and we need 2 bags. 2 bags of marbles, and each one is 2 centimeters cubed. All right, like I said, we need to know when you pour these marbles into the container, first of all, what is the volume of the container? And secondly, what is the volume of all the marbles that have been put into this container? And then she says she pours water in to the top, and she says, she's telling you, you need half a liter of water, which means you're also going to need this conversion because they're talking about liters, and we're not going to be working with liters in our calculations. Where do I start, ladies and gentlemen? What do I do? I know you know what to do. Come on now. Where's my people? Gabo. I know you know. Ben, come on now. Where's my people? Tiamo, even Tiamo, come on now. What do I do here? What do I do with this one? Ben, come on, Ben. No, Tiamo, it's not. Oh no. Okay. All right. Let's finish off. I'll quickly show you. All right. First of all, we need to the volume of the container. Okay. So we're going to do a formula for the volume of the container. So 2 times pi, and they tell us pi is 3,142. All right. 3,142. I'll quickly show you guys. All right. I'll help you out here. 2 times pi, which is 3,142. 3,142 times the radius. Now the radius is not given to us. They gave us a diameter. So we're going to have to cut this diameter in half. So that's the radius squared. All right. And we need to multiply by height. Okay. Now the height's in centimeters, which is an issue. All right. I'm going to write 30 centimeters here. So this is an example of where if you write the units like here always tells you to do, we've got millimeters and centimeters in one formula. It's no good. You can't have that. So one of them will have to change. Now, I think we need to work with centimeters cubed. So we're going to change our diameter to 6,4 centimeters, right? You just divide by 10 and you get 6,4. All right, that'll give us the volume of the container. So now we're going to put this all in. So 2 times, why did I say 2? There shouldn't be a 2. No, there shouldn't be a 2. Don't need this 2. I'm thinking of the surface area. All right, so let's put it into our formula. So 3,142, that is the pi. The radius is, I'll put a bracket here, so it's 6,4 centimeters. And that needs to be divided by 2 because that's a diameter. The radius is the diameter halved, and that's r squared. Now we're going to times it by the height, which is 30. This will give us a volume 965.224. So 965.224 centimeters cubed. That is the volume of the container. Now the marbles are each 2 centimeters cubed, and we have 2 bags of 100. So we're going to say 2 times 100. That it gives us 200 marbles, and each marble is 2 centimeters cubed. So we need 200 marbles, and each one is 2 centimeters cubed. So 2 times 100, 200 marbles times 2 centimeters cubed gives us 400 centimeters cubed. So that's the volume that all the marbles will take up. Okay, so we've got the volume of the container and we've got the volume of the marbles now. Now we're going to find the difference. Okay, so we're going to say 965,2224 minus 400, and you can see straight away that the answer is going to be 565,2224 centimeters cubed. Now, she says it's half a liter. All right. Well, we know that 1,000 centimeters cubed, this is given to you, is 1 liter. So we've got to change our centimeters cubed into liters. So we know every 1,000 centimeters cubed is a liter. So I need to take my answer at 565,2224 and divide it by 1,000. All right, divided by 1,000. And this will give us 565.2224 divided by 1,000. 0,565 centimeters cubed. That'll round off to 0,57 centimeters. Oh, not centimeters cubed. Sorry, liters. We've converted it. It's liters now. All right. Now let's go back to the question. She says, Lindiwe states that more than half a liter of water is required. Her statement is true. The difference between the volume of the can and the volume of all the marbles is 0.57 liters, more than half a liter.